Hello, this is the third part of actually completing the square. As you've probably noticed, I've changed my filming location. What I'm going to do in this video is I'm going to go through a few more examples of using the completing the square method to graph a quadratic, and also go through a few questions in your text from the textbook chapter that I've given you. So let's go through this example. This first example, I want to sketch the graph x squared plus x plus 1 on a Cartesian plane. So let me go through the steps. I'm going to go through it with a bit of picking up the pace now. Now here, the first step I'm going to do is I'm going to check the concavity. So how do I check the concavity? I look at the coefficient or the number before my x. So if you have a look here, my x squared term. If you have a look here, there's no number, which means I have an implied 1. So a is equal to 1 here. Now, because I have a is equal to 1, that is a positive value. So that tells me that my graph is concave up. So what that looks like is my graph is going to look like this. I'm going to have an upwards facing parabola. It's like a smiley face. Okay, step 2 is we want to find the y-intercept. Now, what I said before was that you substitute x is equal to 0 into your parabola. Now, what you notice is that hopefully, if you substitute x into your parabola, these two terms will disappear, and so all we're looking for is just this term at the end. So I'm going to quickly do that. So therefore, y-intercept is equal to 1. It's just my constant term at the end. That's a nifty little trick that I didn't mention earlier. I'm sorry about that. Hopefully you can pick that up for your future, when you're doing these questions in the future. Now, the third step when we're trying to graph this by using the completing the square method is that we actually complete the square. Complete the square. Now let's have a look. My x squared coefficient is 1, so I can actually deal with that nice and easily. When we're doing this, completing the square method, what do we need to do? The first step, I look at my coefficient of my x term. That's 1. What do I do with that 1? I'm going to halve it and then square the result, which will actually give me a quarter. Then when I've done that, I'm going to insert that a quarter into my equation or my quadratic function right after the x term. So I've got x squared plus x. Then I'm going to do that funky plus a quarter, minus a quarter, so they balance each other out. And at the end, I still got that plus 1 in my equation here. So I'm going to just erase so that we can see it a little bit better. Oh, whenever that decides to work. Okay, cool. Okay, so I've got x squared plus x plus a quarter minus a quarter plus 1. Now, from here, what do? Well, we group the first 3 terms because they form a perfect square. So here, this actually ends up becoming x plus a half all squared. Now, if you're not sure about what number to put in that all squared, in this number here, what you'll notice is that it's the same number as this thing over here. It's just a number that I squared in order to get that number that I'm adding or subtracting. So that's a nifty little trick to notice. Okay, here I've got negative a quarter plus 1. So I'm going to have 3/4. So my completed the squared version is x plus a half all squared plus 3/4. And so from here, we can read off the vertex really easily. So the vertex, if you remember, is just so I'm going to write underneath, in vertex form, is just going to be like this. So the vertex HK. What I'm going to write here for my vertex is actually negative half, because if you look, I've in my completed the square form that I've done, I've got x plus a half all squared. In the version that we need x minus h all squared. So here, I'm actually going to take a negative a half to make it fit that version. Negative a half, and k is just my 3/4 over here. 3/4. Okay, so I've got my vertex. Now that I've done that, I'm going to check if I've any x-intercepts. So if I'm checking x-intercepts, I'm solving for y is equal to 0. So check x-int. So what I'm going to do is I'm going to take this thing over here. I'm going to just let it equal to 0. So I've got x plus a half. I'm going to write this in black. So here I've got, if this decides to work, x plus a half all squared plus 3/4 is equal to 0. Okay. Now let's solve this quadratic here. So the first step I'm going to do is I'm going to move that I'm going to move that 3/4 to the other side, so it becomes minus 3/4, x plus a half all squared. Okay, now when I'm solving this, if I want to take this square root of this thing over here, I just need to remember that I've got the positive and negative solutions here. So I've got x plus a half is going to be plus or minus square root negative 3 over 4. Now at this point, some of you might have a bell ringing in your head. You might be like, oh no, something's going wrong. And if you were to put this in your calculator, something would actually go wrong. What you'll notice is if you put square root negative 3 over 4, you get a math error. Now the reason for that, we've already mentioned this in class, is that we can't actually take a square root of a negative number. So from here, because we can't take a negative square root of a negative number, we actually have a conclusion that we can make. This tells us that there are no X-intercepts. So let me just draw a quick sketch. We already know that the graph is concave up. What this will mean is that if I was to graph my graph, it's going to look something like this. The graph, if you have noticed the orange graph, it never touches the x-axis down here. It never touches this x-axis over here. It's always above the x-axis, so that tells me, so by doing this step, it actually tells me I have no x-intercepts. Okay, cool. Now that we've done that and we've done all these steps, what I'm going to do is I'm going to graph the quadratic function using all the information that I have here. Now, in the previous example, hopefully you'll notice that I've actually shifted the, the Cartesian plane a little bit. What I'm going to show you is how I actually do this using the information I got. Now, the most important part that I'm going to actually look for when I'm doing this step is I'm going to, or where to position my axis, is looking at the vertex. So here I notice that the vertex is negative 2.5, 3/4. So here I'm actually, because I know it's negative half, I'm going to actually shift my Cartesian plane a little bit to the right. So I'm going to shift the y-axis a little bit to the right. Now, along with this, I'm actually not going to draw on any of my important information yet. The reason being is when I actually draw it, trying to fit in all those points, as you noticed in the previous example, it's a little bit clunky and it doesn't quite look like a parabola. What I'm going to do is I'm going to notice roughly where all my information is, and then I'm going to draw a rough parabola and then label on the parts after that. So what I notice is that it's concave up, so I know that the graph is going to look something like this. I know that from the completed square form, I know that the vertex is negative 1/2, 3/4, so it's somewhere around here. I'm not going to actually put the point on yet. I'm just drawing a dot around here so I know where it is. I know the y-intercept is at 1, and so I know somewhere around here-ish. It's a little bit above that vertex. So I know all that information. So what I'm going to do is I'm not going to actually put on any points. I'm going to draw the parabola first. So here I'm just going to draw a rough parabola. Oh, even my regular drawing of a parabola is terrible. Oh dear. So I'm going to draw a rough parabola. Okay, that was also bad. Oh man, my OCD is kicking in really hard right now. Okay, that's a little bit better. I'm still not happy about it, but what can you do? Okay, here, I'm going to label on the important part. So at the vertex down here, I'm going to have, that is at negative 1/2, 3/4. Okay, cool. So that's the first part of my parabola. Then I've also got the y-intercept was at 1, so I can put a dash here, and that's at 1. And the final bit, which I didn't mention, was for all parabolas, what you usually want to do is you want to actually have 3 points on your parabola. What I'm going to do is I'm going to put in a point anywhere on my parabola. You can sub in any number that you'd like, preferably not one of the numbers that we've dealt with. So I'm going to actually substitute negative 1 here. So at negative 1, I think if you substitute it into your parabola, it will actually give you 1. So it should line up over here. So this is negative 1, 1. Okay. So those are my key pieces of information. I'm going to label my parabola y is equal to x squared plus x plus 1. And there we have it. That's our parabola that we need to draw here. So hopefully you've started to get the hang of these 4 steps that we're going to do. The more important stuff to notice here for this example is that if the number that I'm taking the square root of when I check the x-intercepts, if that number is negative, that means that I don't have any x-intercepts. That means they have no real roots here. And we're actually going to deal with that in the following section when we have a look at it in when we're graphing by using the quadratic function formula. Okay, so that's this equation here. That's these steps here. Okay.